làm sao nào? Assalamualaikum. Good afternoon, class. While we are waiting for the other 100 people who has not come in yet, baru 200 saja kan, about 200 plus je kat sini. So if the rest of you, if you have any question you want to ask, we can maybe ask questions first before we go to the lecture. Anybody? Or you want to ask through the chat? Next week's test. Okay, all right. Let me double check, yeah. If I'm not mistaken. Okay. Next week is test about some alternative assessment, right? Wait. Alternative assessment, which supposed to replace your final exam. Okay, so instead of giving you questions, please. Okay. So usually in a normal situation, at the end of the semester, you will have final at the Dewan Peperiksaan, right? You're all second year students, right? So first year you already had final exam at the Peperiksaan building, right? Correct? You had a face-to-face regular classes for your first semester, right? Only the second semester we started MCO, correct? Betul tak?
I think during their first year.
During first year, tapi only second sem kot. First sem also.
First sem, right? First year, second sem online kan?
So first sem you had the final exam as normal, right? Dekat at the Dewan Peperiksaan. So you see that is normally that's what would happen. And when you have a soalan question at the Dewan Peperiksaan, you get this whole sheet of question, and then you have questions such as regularly we have something like draw an ER diagram, and then you would be given a case study, and then you will have to draw ER diagram, there and then. So we don't do it this like that this time. So this time, for one of the summative exam, the alternative assessment, we will ask you to draw up a poster. So if you are not sure how to what poster, you will have to, I think, take this weekend to actually learn how you would draw up a poster. You can use PDF, you can use PowerPoint slide, but at the end of the day, you are going to send us a file which we can just click open, and then it will be a poster, and we can look at all your information there. So you will be given some question, and then based on that question, you will have to write up your answer in the poster style and in an informatic style. See, the reason we do something like this is that so each student will use their creativity, because you're at home, right? You have a lot of resources around you, so we cannot ask you a straightforward question like everybody give the same answer, because we cannot give you too much online quiz like the one that we did for the test, right? So we cannot give too many of that, so we have to sort of add different ways of asking questions. So for this one, you will have to draw up a poster. So please learn how to draw posters. So when go back, and Google what are some samples of infographic, so you will have to put your answers in a very nice creative way, but not forgetting you have to make sure your content is correct lah. Yeah. Okay. What is this? Okay. We will finish talk about the test first, and we'll talk about the oracle. Yeah, we talk about the test first. Okay. So a specific date. I think I can't remember. We give 2 days, ke Dr. Jihan? Do you have the? I don't have. I can't remember. You will be given, I think, either a day or 2 days. We went once.
Let me check, Dr. Fariza.
Okay.
Let me check for a while.
Okay. All right. But usually, what we do is we put it on the, of course, on the quiz platform. It will still be on the quiz platform, because the reason it's on the quiz platform is so that once you open, you look at the question, then you will keep track of how long before you submit, right? So if it's 2 days, you have 2 days before it will track how long you will submit after you open the question. You open the question, you go and do your poster, whatever, and then you submit it through the quiz. Also, you can submit through the quiz. So can we have specific date? We will probably, what we do usually is we will open it from what time to what day, and then so anytime during that period of time you'll be able to open, but you must submit within that whatever 1 day or 1/2 day or 2 days. I can't remember exactly. It has gone.
Fariza, okay, yeah, I have checked. Submission should be done 1 day after the question is given to student.
Okay, so
1 day.
you open, and then 1 day you have to open. You have to submit. All right. Thank you, Dr. Jihan. So we will probably open maybe for 2 days, but then you can maybe open on the first day, but then you have to submit after 1 day, or you can open the second day and then you have to submit within that 24 hours, something like that. Yeah. Because the reason that we don't open it at the same time, like an online online quiz is because we don't want people to jam in submitting, right? So you submit. Some people may submit earlier, some people must submit later, as long as it's within that 1 day frame, 24-hour frame. Okay, so test okay, I understand, because I want to okay, I want to answer other questions. Yes.
For the poster, is it same question for everyone?
It's similar question, but there are some differences.
Oh, okay, got it.
Okay, assignment. The bridge entity counted as one of the entity. Yeah. I mean, at the end of the day, you may you will maybe have about um, 12, 15, including the bridge. If you have a lot of bridge, then maybe 8 should not be the minimum lah. Um, like you said here, your question here is the bridge entity counted as one of the entity. You said before 8 to 12. So if you have 8 that includes the bridge entity, maybe a little bit too small, if you have 2 or 3 bridge entities. So if you have 12, 15 including bridge entity, that should be okay. Huh? Oracle database install applicable for local hosts. Yeah, at the moment, the one that we have last time, it's only for local. I believe there are someone the other day shared the one that is online. Maybe you can share that one. I'm not sure. So yes, it's local. So one person will have to be in charge. But when you are working on it, you can still work on it together, right? Yeah. Unless there is a new some other even MySQL, I think it's still local. So unless there is other tools that allows for online sharing, I'm not sure. I'm really not sure about that. I'm really sorry, because I have not been using that, because all this while students have been working together, so I have really not checked if there is any database that you can actually work together in collaboration. Right now it's local host server only. Right? If anybody has any other information, you are free to share it. We invite you to share your knowledge with the class. If you have something that is you can collaborate with other users at the same time. Right? Normally, bridge entity consists of composite key. Normally, yes, but not it will use both keys. You can use a composite key as a primary key, but if you don't want to, you can create a new attribute as a primary key. However, the primary key from both from both other entities will be there as foreign key. Yeah. Moyhausen asked the question. Normal entity consists of composite key. Most of the time, yes. It's the easiest way to do it. Yeah, you just take one key from the other entity, and another key from the other entity, and then you join it to become a composite key and make that your primary key. Okay, upload SQL on server. Okay, Muhammad Nur Hafiz has experience here. Upload my SQL on server, so you can try that. Look at on YouTube, yeah, because I have not really looked at it. Can't see my face. Background tinggi kan, apa cerah kan, tak payahlah tengok. You can just see my outline. Okay, cukup kan? Syafiqah, tak payah tengok muka, tak apa. Nak tengok saya senyum ke? Right, any other question? Did I miss any question? Mysterious. Mysterious bagus what? tak adanya beautiful my smile. Garang ada. Okay, look sekejap bukan. Okay, can you see? Alright, that's it. Sebab this is my only spot yang I suka duduk, you know, because otherwise tak best. Okay. Okay, any other question? So can we start the class? We start the lecture, yeah? Alright, okay, let me share my, alamak, let me share my screen. Can you see my screen? Everyone?
Yes.
Can you see my screen?
Yes.
Okay. Alright. Okay, so the last week we talked about database design, and what you have done so far is top-down approach. Remember, we talked about you look at your business rules, and then you figure out what are the entities from your business rules, and then when you look at your entities, you determine what are the attributes for each of those entities. Okay, this is top-down. But sometimes when you go, okay, let's talk about top down. Okay, so when you have those entities and your attributes, those are going to become your tables, right? Okay, so one thing that you should do to verify is to do this process called normalization. And you want to ensure that each of your table is in what you call a third normal form. Okay, so when you do a design of your database, in many cases, you want to ensure that your tables are already in the third normal form. There are other normal forms beyond the third, but in many cases, as long as you are in the third normal form, your database is quite okay. Yeah, it's will be able to function quite well, right? So what is a third normal form? So tables can be in various normal forms. It can start with first normal form, second normal form, third normal form. It can even go to the fourth, fifth, and so on. So in this lecture, all right, so we will look at how normal forms can be transformed from lower normal forms to a higher normal form. Normalization and ER modeling are used concurrently to produce a good database design. Okay, some situations require denormalization to generate information efficiently. So sometimes your tables are too normalized that you may want to denormalize them. That is, if you are looking at a complex design where you have a lot of decentralization. Somebody may have already created this database, this table, and another. Remember the decentralized design whereby separate teams are working on separate areas of the database. So this person may have created tables, and this person created tables. These tables are maybe too normalized, and you may have to denormalize and join the tables back together, but at this point we will just look at a more, let you understand the basic, which is from first to the third normal form only. We're not going to look so much into denormalization, but just for you to know that there is a situation where you may have to denormalize also. Okay. Sekejap ya. All right. So why do we want to ensure that our tables are properly normalized? If our table is not at the proper third normal form, yeah, this is how you note your notation. The notation is 1NF, 2NF, 3NF. Yeah? If your table is not properly normalized to the third normal form, you will have anomalies. Okay, remember what anomalies are? Um, you have insertion anomaly, deletion anomaly, modification anomaly. Remember? So if you don't remember, go back and check what is anomaly. So if you don't normalize your tables properly, you will have anomalies, meaning that, for example, if you want to update one of the address of a customer, you may have to update many times because your table is not normalized properly. Okay, so that would be one problem that your database may have. All right. So in in concept, higher normal forms are better than lower normal form. So second normal form is better than first normal form, and the third normal form is better than the second normal form. Is fourth normal form better than third normal form? Okay, this is where a lot of people would say that for normal usage, third normal form is just as good. Yeah, third normal form is as high as what you need in a normalization. Okay, um, if you go to advanced databases, maybe you want to look at other higher level of normal forms. Yeah, but it's not. It is it at a certain point it becomes more of a theoretical thing. Yeah, because in reality, third normal form is good enough. Yeah. Denormalization produces a lower normal form. So if you have, you are maybe at the fourth normal form, because of the way that it was designed, like I said, in decentralized situation, then you may want to denormalize and put everything back in the third normal form. Yeah. So results in increased performance. This is where you see, because when it is when it is too normalized at a very high level, you may have to join so many tables together. Yeah, you may have to join so many tables together. Then you will have a very bad performance, because when you have to join so many tables, when you are doing a selection, we will look at select statement later next week. When you have to join so many tables together, the performance of the database becomes lower, because there's so much the database has to do. So it takes a longer time for the database to give you a result, because it has to go and look at so many tables. Right? So that's why you will need a denormalization process. Okay. So normalization is needed when you design your database. Like I said, if you are doing a top-down, you may use a normalization process to ensure that your database is in the third normal form. Okay. So sometimes when you do a top-down, sometimes when you create your tables, you do not create it in the proper normal form level yet. Maybe what you have created is actually in the second normal form. You don't know, but you have created your table. And then you go through your normalization process, and then you find out that, oh, this table is actually in second normal form. Then you have to normalize it to the third normal form. Okay. There are some cases when you create your tables, top-down approach, and somehow all your tables that you have created are actually in the third normal form already. But you don't know that, because you have not done normalization. So you go through each tables and you say, oh, this table is already in the third normal form. Okay, so you verify that this table is in the third normal form, because what you justify it. And then you go to the second table. Yeah, this table is also in the third normal form, because what so you go through the normalization process to verify that your table is already good to go, right? So the objective of the normalization is to ensure that each table conforms to the concept of well-formed relation. meaning that each table must represent a single subject. So your table you should be about a single subject. Like if it's about student, your table should be about student only. It should not have other additional stuff, on the table. Because if it does, doing the normalization process would actually show you that. Okay. No data item will be unnecessarily stored in more than one table. So you will not have unnecessary data, no redundancy. In other words, you don't have redundancy. And you will have all the attributes are dependent on the primary key. Okay, so all your attributes in your table are dependent on the primary key. So each table is void of insertion, update, and deletion anomalies. So like just now we said, like I mentioned, so you don't have anomalies. That is the objective of your design. You want tables that do not have any anomalies. So the process is to ensure that all tables are in at least third normal form. You say higher forms are not likely to be encountered in business environment. If you're in a business environment, you don't need higher forms. Yeah. So when you do your normalization process, you look at one table or one relation at a time. At one time, you look at one, and then you've done with this one, you look at another one. Yeah. So you start by identifying the dependencies of the table of the relation, and then progressively break the relation into a new set of relations. So you start with one relation, one table, and then when you do your normalization, you may have to break this table into several other tables or several other relations. Remember, tables and relations are actually the same thing, right? Remember, it's just a matter of you are talking in what lingo. Yeah, if you're talking about relational database, you talk about relationship. You're talking about normal. If you're talking about the implementation, the relation has become tables, right? So table relation, basically the same thing. So you start with a table or a relation, and then you break it down. You may come up with two or more tables, right? Okay. So this one you will have to first try to remember. Okay, so you will have your table either in an unnormalized form, and then your table may be then translated or transformed into a table which is in the first normal form. A table in the first normal form, you identify the primary key. You have no repeating groups. Okay, this is the description. The description of a table in a first normal form. It has the primary key and it has no repeating group. Second normal form, table in a second normal form is already in the first normal form. That means it has a primary key, it has no repeating group, and it has no partial dependency. You must try to just remember this. In second normal form, it has no partial dependency. What is partial dependency? We will look at it afterwards. Okay, it has no partial dependency. Tables in the third normal form must already be in the second normal form, meaning that it has the PK, identified primary key, it has no repeating group, it has no partial dependencies, and it has no transitive dependency. All right, I'm not going to talk about voice chord and fourth normal form. All right, I'm just going to go through the first, second, and third only. All right, so what do you mean by dependence? What do you mean by dependence? This is a lot of things to try to read and understand, but later on I will try to show you. You say that an attribute is fully dependent on an attribute A if the value of attribute A can determine one and only one value of B. Very difficult to understand, right? Okay, the attribute B is functionally dependent on attribute A if a value of the attribute A can determine one and only one value of B. Okay, example. I'm just going to give you some example. I don't know. Let's see if I have a good. Okay. Let me see. Okay, I don't know whether you can see this table or not. You look at this table. You have employee number, employee name. Okay, let's just look at employee number and employee name. Okay, so employee name is functionally dependent on employee number. That is the statement I'm going to give you. Employee name, okay, employee name is functionally dependent on employee number. Why? Because when I say employee number 101, I know that it refers to, it refers to this name. Okay, this is employee 101. It refers to news. It does not refer to Alonso. It does not refer to Senko, or it doesn't refer to Jones. It only refers to news. So meaning that employee name is dependent on employee number, because the value of employee number determines only this value. Okay, so you try to go back and look at it that way. Okay, all right, so attribute B is fully functionally dependent on attribute A if each of value A determines only one and only one of value B. Okay, attribute A determines, okay, so attribute A determines attribute B if all the rows in the table that agree in the value for attribute A also agree in the value for attribute B. I don't know what this is, so I'm sendiri pun tak faham. Okay, but basically that's what it is. Yeah, basically that's what you need to understand. This is basically telling you pretty much the same. Yeah, pretty much the same. We will come back to, you will try to understand this later, but that's what it is. So when you have functional dependency, just now remember, second normal form says it does not have partial dependency. Third normal form says it does not have transitive dependency. So what is partial dependency? What is transitive dependency? Functional dependency is the dependence in which the determinant is only part of the primary key. Only part of the primary key. Meaning that it should be a composite key, because a composite key have two parts of the primary key, right? I'm not going to read all this. I myself can't understand what this is. Partial dependency, meaning that dependent only on part of the primary key. So you must have a composite key. Then only you can have a situation where there is, that you can actually show that there is a partial dependency, meaning that it is dependent only part of the primary key. A transitive dependency is the attribute depends on another attribute which is not the key. Because what you've seen before is attributes are dependent on the primary key. In this case, you have attributes which is dependent on some other key which is not a primary key. Sorry, some other attribute which is not the primary key. Okay. On this one, you will have attributes dependent on part of the primary key. Okay. I know I may sound confusing, but hopefully you can get it later when you see more examples. Okay, so first normal form, no repeating group. What is a repeating group? A repeating group is a group of multiple entries of same type can exist for any single key attribute occurrence. Existence proves the presence of data redundancy. So basically, I will just, I mean, don't worry, we don't ask all these definitions, okay, in your exam. So you really don't have to memorize this, because I myself cannot memorize this. But what I understand that I can tell you is that, first of all, when there are different approach to looking at first normal form, but all I want you to be able to understand is when you have a table and for every cell in the table you only have one value, you are already in the first normal form. Okay, you are already in the first normal form. Example. Okay, if you have this is not first normal form. This is not first normal form, because here you don't have value, you don't have value, you don't have value. Yeah, so this is not first normal form. This is first normal form. You may have redundancy here, but it's okay. But in every single cell, you only have one value. Yeah. If you look at this one, this is also not the first normal form, because if you want to make it this as one cell cannot have multiple values. Okay, cannot have multiple values. So either way, however you want to define it, all I want you to understand is when this format, this is already a normal form. Every single cell has only one value. No repeating groups, whatever repeating group it means, every single cell has only one value. Okay, so so if you have a situation like this, you want to convert it to become like this. All right, you want to convert it to become like this. So this is your first normal form. Okay, so in your first normal form, can you see anomalies or not? Can you give an example of can you give me an example of deletion? Maybe you can't find here. Update anomaly. Give me an example of update anomaly that happens with this particular form, with this particular data. Anybody? Saya tak nak bagi jawapan. Give me an example. There is an update anomaly here.
So I'm gonna try. For example, when you update the project name on only one entry, the project name.
The project name, okay.
Only one entry. If you don't update the rest, then there will be, like, how to say, update anomaly, I guess, because
if you want to change this project name to Evergreen 1, for example, right? You have to update every single line, correct? You cannot just update one line. So that is an update anomaly. Okay, if you want to update something, you may have to update more than one line. Right? If you have tolong tengok apa. So if you have a proper table, if you want to update the project name, you should be able just to update another table called project. Just change the project name in one line. That should be the way, the correct way. But in this case, you have anomaly because you have to update every single line. Let's say you have 1,000 line for project number 15. Then you have to update 1,000 lines. Okay, so this is not a good design. All right. So that is an example of of anomalies that will exist if you don't normalize your table properly. Okay, so now you have that first normal form. You want to update, you want to transform to a second normal form. How do you do it? Right, so you first start with a dependency diagram. So in a dependency diagram, you would, apa ini? In a dependency diagram, you would draw out all the dependencies, the partial dependencies, the fully functional dependencies, and the transitive dependencies. Because you will have to draw all this, then it will be clear for you. All right, so again, all right. So I think let's skip all this definition. You'll just read it later once you understand. Okay, so this is what you call a dependency diagram. Okay, remember this table just now? Okay, this table. So you have what? You have 1, 2, 3, 4, 5, 6, 7 attributes. Okay, you have 7 attributes. First of all, you need to determine what is the primary key for this table. What is the primary key for this table? A key which will be able to identify the whole row uniquely.
Project number.
Yeah?
Employee number.
Project number.
Employee number. Are you sure?
Composite key of project number and employee number.
Yeah. Okay. So you can give it a try, right? Okay. Let's say if it's employee number. If it's employee number, you will see that you may have one employee in 1 or 2 rows, right? You have employee number 105 here. You have one employee number 105 here. All right. What does that mean? This is about, if you look at this again, you need to understand the data. What is the data about? So this is about projects, right? You have 1, 2, this company has 4 projects. So for each of the project, they have many employees. Okay, so these are the business rules. I'm coming up with the business rules when I look at this. This is a report. So this can be your business, this can be a source that you get from your company. Let's say like now you're doing a project, right? So you can go to the company and you look at the report. This is a layout of the report. From the report, you can see, oh, this company is running a few projects, correct? Each project will have its name. Each project will have many employees. Each employee got their own name. It has their job class, charge per hour, hours bill, and the total charge, how much you will get. This thing plus times this thing, you'll get this, right? Okay, and then you will see, oh, an employee can work in more than one project. Employee Alice is here, and Alice is also working in this particular project. And for Alice, every time she works, she is always a database designer. Okay, because from this data, you will know the rule is that the Alice always work as a database designer. Let's see some other. Is there anybody else? 101. John also works in 2 different projects. Every time, John is also a database designer. Are they paid the same? All database designers are paid the same. All system analysts are paid the same. All general support are paid the same. Do they work the same hours? Let's look at Alice. Alice works 65 hours for this particular project. Alice works for 35 hours for this project. So Alice can work in more than one project, but for each project she will work on different hours. Yeah, she is actually working longer on the 3rd project. All right. So when you're looking at this, can employee number be the key? Can employee number be the key? Cannot, because employee number is in more than one rows, right? It's more than one row, so it's not unique. Can project number be the key? Cannot, because you have 5 rows having the same value. So like somebody mentioned just now, if you combine project number and employee number, then you will have a unique key, right? So if you combine project number 15 for employee 103, this is the data. This is how much this is how much they're working. Sorry, this is how much this is how long they're working for that hour. For Alice in 15 and 105, for this one is 37. For Alice 105 for this, for project number 22, for employee number 105, this is working hours is 64. But how come everything else is the same? You know, for Alice here, the 15 and 105, for example, this is same evergreen. This is sorry, evergreen is not the same. Where is my name is Alice. Database designer is the same. This one also Alice. Alice database designer the same. Rate is also the same. Rate is also the same. So this is to show you, from here you can see that there is already redundant data, right? Okay, so you can see that this is not a good design yet. Okay, so we go to the dependency diagram. So you know that the key is project number and project num. So you underline that project number, project num. So remember what is the second, what is a partial dependency just now? Dependent on part of the primary key. Dependent on attributes that are dependent on part of the primary key. So this is the primary key, this is the primary key. Part of the primary key means this is one part of the primary key. This is another part of the primary key. So now you break it down. Break down that primary key into two. So which attribute is dependent on project num? Which attribute is dependent on project num? If you look at the data here, you will know that whenever what is fully functional just now, that value, the value of A will always determine one value of B, right? So project num will always be evergreen. Can project num be amber wave? Cannot, right? Amber wave is 18. So project num determines project name, or project name is dependent on project num. Okay, faham tak? So project name is dependent on project num. So because this is part of the key just now, so this is partial dependency. Okay, project num determines project name. Same thing. Yeah.
Hello, Mac.
Question?
Sorry, but can we not say like project name determine project number? Why cannot we say like that?
Okay, why you cannot say? Good question. Okay. Well, because the key just now, because the key minus tadi, okay, because we have determined that I'm sorry, I'm going backwards. Because we have determined just now that the key is project num. We have determined that the project key, the key is project num. So the key determines the attribute. Okay, because this is the key. And why do we make this the key and not this the key? It's just your choice. But then if you think about it, of course, using project num as the key is better because it's shorter. So because when you choose a key, it has to be something which you don't make error. Because if you use project name, you might have typo, right? You have so much longer to key in. You might have typo. You may have sometimes, yeah, basically you can have typo, right? So if you look at the deep definition here, at the functional dependence is each value of A determines one and only one value of B. B is fully functional dependent on the attribute A. And basically it is always dependent on a key. Yeah, if B is dependent on attribute A, that means A is the key. A determines B. So when you ask why we cannot say project name determines 15, because project num here is the key. So it's always like this determine this. So this is dependent on this. But if you are putting the project name as a key, then yeah, you can say it the other way. But like I said, project name is not a good choice to become the key. Project name is still the best to become the key. Yeah.
Okay,
Right.
thank you, madam.
Okay. Okay. In this case, employee num, same thing. When you mention one employee number, you will be able to determine employee name, the job class, the charge per hour. Okay, let's look at this. If you are mentioning 105, every time 105, the value must be Alice, right? Here, the value is Alice, right? The job class is database design. For here is also database design. 105, the charge per hour is also 105. Here is also 105. So you can see that every time you say a value 105, it will be able to determine the employee name. It will be able to determine the job class. It will be able to determine the charge per hour. Can it determine the hours or not? It cannot, right? Because for this line, the hour is 35.7. For this line, the hour is 64.7. So that is why when you draw this, the employee num determines the employee name, determines the job class, determines the charge per hour. It does not determine the hour. This hour is actually determined by project num and employee number. When you have project num and employee number, you actually can determine all of this. You can determine this, you can determine this, you can determine this, this and this. That's why you have this arrow right here. This arrow right here says that with this primary key, you can actually determine all this value. Of course, because otherwise it will not be a function. Otherwise it will not be a primary key, right? Okay. So now, to look at the partial dependency, you break up the primary key. This part of the primary key now determines this. This part of the primary key now determines this, this, and this. None of the part of the primary key determines hour. Hour must be determined by both project num and employee number. So far, boleh faham? Understand?
Yes.
Okay. So now we go to the third dependency, which is transitive. What is transitive dependency? Transitive dependency is an attribute functionally dependent on other than non-key. Okay, you have an attribute dependent on other than non-key. So if you look at this, if you look at the charge per hour, all the designers' charge per hour is 105. You look at all the database designer, their charge per hour is 105, meaning that the charge per hour is dependent on the job class, right? If you know what is the job class, you can determine the charge per hour. All right. If you know that the job class is programmer, you know that the charge per hour is 35. Okay. Somebody asked just now, why can't we say a project name determine project num? Okay. So I'm asking the same question now. Why can't we say charge per hour determines job class? In this case, I'm going to ask this question, but the answer is going to be slightly different. Why can't charge per hour determines job class? Why can't we say 105 determines the job class is database design?
Maybe another job class can have the same charge per hour.
Very good. Yeah, because you may have another job class which may have the same 105 as charge per hour. Okay, so that's why you can't say it is the other way around. So job class here in this case determine charge per hour. All right, so you have this diagram. So job class, it's not a key. Yeah, it's not a key, but it determines the charge per hour. So this is a transitive dependency. Okay, so now that you have your dependency diagram, you can draw up your schema, relational schema here. So you will say that, okay, in the first normal form, you have the project num, comma, employee num. Okay, and then you have this is the primary key because it is underlined. Aku punya it is underlined. So these are all the attributes in the schema. So what is your partial dependencies? Partial dependencies is where you have project num determines project name. You have the arrow there. Employee num determines employee name, job class, and charge per hour. And then transitive dependency, you have job class determine charge per hour. Okay, so this is your dependency that you have determined. All right, now, how do you convert? How do you convert? I'm going to talk, you can read this yourself because it's just to say that you're already in the first normal form. Don't want to look at that. Okay, how do you convert to second normal form? You will have to make new tables to eliminate those partial dependency. So you don't want your tables to have partial dependency. So what do? You write each key component on a separate line. Okay, so now you take, just now remember what are the key components? Project num and employee num, right? So you take project num, you write on a new line. You take employee num, you write on a new line. And then write each key component on a separate line, then write original composite key on the last line. Okay. Each component will become a new key table. Okay, so now you have project num on one line, you have employee num on the second line, you have project num, comma, employee num on another line. Okay, so for employee project num, you add on the attribute, which is, what is the attribute just now? Project num, project name, right? Check project num, project name. So that now becomes a table. Okay, and project num will become the key for that new table. And then you have employee num. Employee num, so you add on the attributes. You have what? Employee name, you have database, you have job class, you have hours. So that becomes a new table. Employee num becomes the key in the new table. Okay, so what happened to the original table? Right, the original table now, project num and employee num only have one attribute left. Only have one attribute left because all the other attribute has gone to the new table. So now in the second normal form, you have 3 tables, right? You have 3 tables. Okay, so you will have project num, project name, this is one new table. Employee num, employee name, job class, and charge per hour, this is a new table. And project num, employee number, you have the hour that they work for that particular project as the only attribute left from the original table, right? This is all. This has gone.
Excuse me, doctor, you're lagging.
This is a fully functional dependency. There is no partial dependency here. There is no partial dependency here because this is dependent on both this primary key. It is not dependent on part of the primary key. Okay, so no more partial dependency. So now your tables are all in the second normal form. So if I'm to relate back to your project, if you already have tables like this, You have to look at each of your table and see, okay, are there any partial dependency in this table or not? No, because this table has only one key and has only one what do you call one primary key, one simple primary key, and there is no partial dependency here. Okay, and then this is also no partial dependency, no partial dependency. You have to explain. Okay, so now you look at, is there any transitive dependency or not in any of this table? So what is transitive dependency? You have a you have an attribute dependent on a non-key attribute. So you have already determined this earlier, right? This determines this. Yeah, charge per hour is dependent on the job class. So this is your transitive dependency. You don't have transitive dependency here. You don't have transitive dependency here. So this has already automatically gone or achieved third normal form. Because this has no partial dependency, this has no transitive dependency, this table has already achieved third normal form. This table has no partial dependency, this table has no transitive dependency, this table has already achieved third normal form. Okay, this table has achieved second normal form because it has no partial dependency, but it has transitive dependency. So in order to change this or to transform this to the third normal form, you have to remove the transitive dependency. So how do you do that? You take out job class, you take out charge per hour, okay, you take out charge per hour, that becomes a new table. Mana? This becomes a new table. You take out the job class, you take out the charge per hour, that becomes a new table. Project name, earlier on same. Project number, employee name, assigned hour, still the same. What happens to this table just now? What happens to this table? Okay, you have still the primary key. You still have this. You have taken out this. You have to keep a copy of job class because this will become the foreign key that will have that relationship with the other table. So you have to keep this. This becomes a foreign key now that will link it to this particular table. All right. So this you have to leave it behind, a copy of it. So from that one table, now you have 4 tables in the third normal form. So this is how you would do your normalization. In terms of how does it being used in your design is, one, you use it as a verification tool. You want to verify whether your tables are already in the third normal form or not. Or sometimes, because when you do your top down, you may also find in your resources, when you do your interview and so on, when you collecting your business rules, you get this type of a report. So this type of a report is basically a bottom-up design approach, whereby you already have your attributes. From these attributes, you are breaking it down into 4 tables. So can you see? So in top down, you start with your entity. In bottom up, you start with the attributes. From the attributes, you do your normalization process and you get 4 new tables. Okay? So when you do it concurrently, you may already, maybe when you are looking at the when you are interviewing your users, you already come up with table project, because when the user tells you, okay, yeah, we have projects, and the projects have many employees, already you already have project table, employee table. You already have those entity, and then when you do this, you will see, oh yeah, I already have project table, I already have employee table, so it now reinforce your earlier top-down design. Okay, so you can, so it sort of, it can complement, it can work as a verification, and so on. Yeah. All right. So things that you want to look at is, you may want to look at your naming conventions. All right. You want to see whether your data can be further subdivided or not, atomicity, right? And then sometimes you may even want to add some new attributes and so on. Okay, let's look at an example. Project. What is this? Project. Okay. Okay. Let's say you may want to add other attributes. For example, here, maybe you may have a manager or supervisor for that particular project. Okay, the supervisor is or the leader of the project is an employee. So you can add, you don't have to add a different attribute. You can just use employee num to determine who is to keep the data on who is the leader of the project. Okay, because this would actually gives you a relationship whereby a project is supervised by an employee. Okay, that's why you will have the employee number becomes the foreign key of that table. It has a relationship with the employee table. Yeah, but you cannot put this cannot be the members of the project, because in a project you have many members, so you cannot put the employee numbers of the employee number for each member in this table, in the project table. Yeah, because you have more than one. You can only have one. That value here is possible for the supervisor. Yeah, so you can have a situation whereby after you remove the employee number, but you can add a new column, employee number, in this case for the supervisor, yeah, not for the members. I hope you understand what I'm saying. Yeah? All right. And then look at the table here just now. Job class. What is the data for job class? Look at the data for job class. Data is here, this one, right? So, like I said just now, when you have description like this, and then when you break down the tables, you have job class becoming the primary key. However, when you have a long list of text like that is not good to become the key. So you can add job code as the key, and this becomes a job description. All right. So to make your database better, you can add some new attributes and so on. Yeah, to help in making your design better. So this is something that you can do also. What is this assignment? Okay. All right. So then you may have, because remember just now you have project number and project num. Project number, project num, and you have how many hours assigned to that. So this was your original, the original one that you have left, right? So you may have other information that you want, whereby assign how much hours is assigned to that person, and in this case, you have let's look at 105 here. This is charged by 1105, 105% of what assigned charge per hour. Assigned charge. Yeah, because in this case, you want to calculate how much total this person would get from each project, right? So you may want to have you may want to add some other attributes, yeah. So because if you look at here, if you look at this, right, employee num, you don't know how much the charge per hour for this employee right now, right? You don't know. So you will have to go to here, and then from here you will have to go to here. So sometimes you may have to join, in this case, 3 tables. Okay, 3 tables. So this is your first initial design. If, now I'm not saying everybody has to do it. If in your situation for that particular company, it is very important that they want to calculate this a lot. So instead of joining so many tables altogether, you may want to add back this data, so that you can easily calculate. But here you can see that there is also transitive dependency here. Yeah. So employee name, okay. All right. Job code. Do you have this? Let me see here. Okay. So job class instead. So now remember here we put job class as the what you call the primary key here. But remember we changed the job class to not become the primary key anymore. The primary key is a now job code. Okay, so now you have to go back and change this instead of job class, but to include job code as the foreign key now. Okay, so you need to do. So as I said, it's iterative. So once you change a little bit, you have to improve other things. Yeah, so you need to look at that. So maybe you want to include other things like hire date, because these are the data about the employee. So you have the name, you have the hire date, job code. Maybe you can have other things also, telephone number and so on. Yeah. All right. Primary keys. Okay. Surrogate key. Surrogate keys. Sometimes you will have database DBMS. Yeah, DBMS assign automatic keys for you. Okay. This is when primary key is considered to be unsuitable. This is system defined, managed by the DBMS. It usually is a numeric value which is automatically incremented. So the key is like this, maybe start with 1 and then it increments, or 101 and then it increments. Yeah. Normalization should be part of the design process. So when you do your ERD, again, you can do it top down. Top down. You can use normalization basically just for verification, or when you do your top down, you may also do concurrent bottom up if you have attributes that you want to group into entities. Yeah, so you will do it concurrently, top down and bottom up. Okay. All right. So this is again from the same data set. So now you will have these tables. Then you have employee num as the key for employee, and then you have all this, and then you have project num, project name. Okay, so now you start drawing your ER diagram. So here one job is for more than one employee, but one employee can only have one job. Okay, you may have, in this case, you may have some job that has not yet have any staff. That's why you may have a job which is not exists in your employee table. So that's why you have an optional here, right? And what about project and employee? So remember just now you have one employee is one employee, one project has many employees. Okay, one employee is assigned to many projects. So you have a many to many here, right? One project, okay, let's see. So one project, so you actually, I wouldn't draw it like this. I would just put many to many, yeah. Okay, so now you have many to many, so you have one employee is assigned to many assignment, one project has many assignment. And then you have one employee manages one project, right? And then you have one job code is for many employee, one employee is only for one job code. So in this case, one employee manage one project is managed by many employee. One employee may manage one project. There are employees who do not manage any project. That's why you have an optional here. Okay. So these are the implemented database. Okay. Denormalization. Again, like I said, denormalization is sometimes when you have number of database that expands, which by you have to join a large number of tables. See, so when the system has to join a large number of tables to do a query, so it will take a lot of input-output operation, a lot of processing logic. So it reduces the speed. So the performance level is down. So you may want to speed it up. So you may want to denormalize it. And denormalize means you're putting back. Like this would be considered denormalization, whereby you want to add back certain things here. You know, because you may want to calculate this. You don't want to be jumping from one place to another just to find what is the charge per hour for that particular person. 105 just now. What is charge per hour? You have to go back and look at who is this person, what is the position, what is the job class, and then what is the assigned charge per hour for that particular class. So in this case, you just denormalize it and you just add this back to this particular table. Yeah. Okay. What else? So defects in unnormalized table, data updates are less efficient because tables are larger, indexing is more cumbersome, no simple strategies for creating virtual tables known as views. Okay, all right. This is it. Okay, just a short understanding test. What do you think? Verify this table. What normal form is this? What normal form is this? In the first place, let's start with primary key. Okay, this is in the first normal form, okay? Because every single cell has only one value. Okay, this is the first normal form. Is it in second normal form? Is it in third normal form? Now you have to think about your partial dependency, transitive dependency. So before you can even know what your dependencies that's available here or that exists here, you need to determine what is the primary key of this table. So what is the primary key of this table?
Patient ID.
Just patient ID. Okay, all right. Anybody else? And patient ID, is that good enough? Primary key, patient ID? Anybody wants to say otherwise? Hello? Anybody disagree?
No, I agree with his answer.
Okay, all right. Okay, again, actually, we need to basically understand what this data is talking about, right? This is appointment. So in this case, you don't have dates, right? You don't have dates. So you're saying that this table is just saying that this patient has an appointment with Dr. Smith in room 324 in the cardiology department. So so in this particular example, I am assuming that we are not bothered about the dates, right? We're not bothered about the dates. So maybe this is possibly just for one day, right? Because if you have an appointment for a different date, then you may have a column that says date, right? But in this case, it doesn't. So I'm assuming that this table is only for appointment for today. Okay, so assuming that the patient will only have one appointment for today, that means there will only be one row for that patient, right? There will be only one row for each patient. So if there is only one row for each patient, then the patient ID can be the primary key. Okay, the patient ID can be the primary key because there will only be one row for each patient. Okay, so let's have that assumption. That's why sometimes when you answering question, you may have to have assumption, but because we don't have a test, okay, never mind. Okay, let's just say we are assuming that this is one patient will only have one appointment for this particular day. So you will have the patient ID as the key. All right. So if the patient ID as the key, is there any partial dependencies or not? Is there any partial dependencies or not? Yes or no?
No.
Why?
How is it possible to have partial dependency if your primary key isn't a composite key?
Yes, because there is no composite key, right? So there is no partial dependency. Definitely cannot be, because this is already patient ID. Is only, there is no part of it. This is the key. No partial dependencies, right? Okay, so when there is no partial dependencies, this is already in the second normal form. Okay, but are there any transitive dependency?
Yes.
Okay, what are the which attributes are dependent on which non-key attribute?
In my opinion, room number and department depends on doctor name.
Okay, so if you look at this data, it looks like the room department, the room number and the department is determined by is dependent on the doctor name. And that means the doctor name Smith will always be in room 324 and he is always in the cardiology department. Okay, so then what you will do is to remove that transitive dependency, you will take out room number and department, put it in another table. The doctor names become the new key, correct? And the doctor name remains in the original appointment table. Okay? Clear? So now you have two tables. First table is patient table. You have patient ID, patient name. His appointment is with whatever doctor. So you have 8023 Anderson. He has an appointment with Dr. Smith. And you have in another table, you have let's say a doctor table. You have the doctor name, you have the room number, you have the department. So you will have how many rows in that particular, in the second, how many rows will you have in the doctor table? How many rows?
4.
4, right? You will have 4 tables. You will just have Smith, you will have Hicks, you will have Hernandez, you will have 4. Like you don't have to repeat Smith twice, you don't have to repeat Hicks twice. So you only have 4 tables. Okay, all right. So basically, looking at just this data that you have here, you will assume that this is in the second normal form and you transform it to the third normal form.
Hello, doctor.
Mm,
In the other table, the doctor name is a primary key, right? And we have the other two column, which is room number and departments.
yes.
But in that table, the room number also determines the department. So, can I say it's transitive dependency?
Okay. Okay. So sometimes you have to use some. This is where things sometimes you need to sort of some nak kata apa macam common sense sikit lah. You could, but then it may not be. You may you what to say? You don't really look at it that way, do you? Like you give a room number and then you know what department it is. Macam you could, but does it make any sense to actually do that? And yeah, if you're looking at this from just this table, from this table, yeah, you can say that 324 is in the cardiology. You could, but
But doctor, I don't think the department number determined by the room number. If you can see, 135 is neurology, and 134 is also neurology. So,
But
I think what he's saying
neurology.
Yeah, what you're saying is you when you know the room, you will know what department it is.
Yeah, because in my opinion, like the room maybe is particular for particular operation.
I would if you want to create a new table called room, that's fine. You can say that it is transitive, yes. Just now, okay, when you say room number 324 will always determine that it is in cardiology. Yes, you theoretically wise, yeah, you can do that. And if you want to create another table called room, yes, you can. You can make that a new table. A room number becomes the room key. The primary key, and department is one of the what do you call, one of the attribute. That is fine also. There's nothing wrong with it. Yeah. On the other hand, just now somebody was mentioned, department cannot determine room number. Okay, macam just not neurology. The department neurology does not determine what room it is because you have two different rooms in neurology department. Okay, so let's try to get this clear again. Yes, you can say that room number determines the department. And because you are saying that this is a transitive, then yes, you can create another new table called room, whereby department will become an attribute. All right, so that, yeah, maybe there is a necessity. You look at the room numbers and you say, okay, yeah, what department is that? Or you look at the room number, you know what is the department. Yeah, it's possible. It's possible. All right.
Thank you, doctor.
Okay. So we will open up the tutorial. I suggest you really do the tutorial because it can be a little bit challenging. So try to do it, and then we will discuss it. We will have we will have synchronous tutorial next week. I cannot say we have asynchronous. Until you all in asynchronous. We will have synchronous tutorial next week. Yeah. So try to do it because I will want you to actually present how you do it. I'm not going to lecture how to do the normalization again. So you will have to present to me how you do the normalization. Okay. So any other question? You want to go back to what? So like I don't want you to be too worried about the definitions, because I myself cannot remember the definitions. But you should be able to implement it. You should be able to at least to understand what is partial, what is transitive, what is fully dependence, things like that. Yeah. Questions?
Excuse me, doctor. For the dependency part, a lot of the explanation only mentions attribute. Can a primary or part of a primary key be dependent on another non-key or a key attribute?
Yeah, actually, yes. Actually, you can have a key being dependent on a non-key attribute. I think that would involve Boy Scout, higher level, but um, you don't have to go to that. You don't have to look at every single, and then it would become very complicated. This would depend on this would depend on this. Just look at it, just one layer first. Does this key determine any attribute? Just look at that. Do you have any attributes which are dependent on this primary key? Do you have any attributes that are dependent on non-primary key? That's it. If you have a primary key which is dependent on a non key, don't worry about that, because that is a higher level, and you don't need it for the running of to implement a database. Yeah?
Thank you, doctor.
Because it will make your database becomes much more complicated. All right. Any other question?
Doctor, for the first normal form, like you said, each cell must be filled with a value, right? How about if it's a null value?
Okay, yeah, you may have some with the null value, but I think what I'm saying is that, okay, let's just look. You see, the difference here is that this null value is actually is repeated, because this is like it should be for this project number, right? This null value should not be here, because for if you look at this data, it has a value, right? It has a value. But if you are looking at some tables which have null value because the data has not been keyed in, like for example here hours, maybe for this particular person the data is not being keyed in yet. That is, you can tell that these are just sparse, sporadically. You may have some null value, but when I'm saying is null value is when you look at it very clearly here, that this data is actually should be in this table. Yeah, because it comes from this, like this evergreen is for all this data. So by right, this data should be in all these rows. We're not talking about null value whereby the data is not known, whether the data has not been keyed in. In this case, it's just that you need to populate it properly. It's not being populated properly, because this is the actual population. Okay.
Okay, understood, doctor.
Yeah. Any other question? Soalan lagi? What is it? It's 2:30.
Doctor?
Yeah?
Can I ask about assignment?
Okay, right.
So in assignment, we only need to normalize the first ERG diagram, right?
You normalize your tables.
Yes, our first table, not first, like first version of the schema design. Is it true? So then we need to do first, second, and until third. Is it?
Because is it okay? That's why I said when you do your first ER diagram, I think you are doing a top down, right? You are doing a top down approach. So you already have your entity. That means you already have your table. So what you do is you will actually do something like this. You will actually do something like this. You have the table, this one. Now you look at it and you say, okay, is this table does it have a partial dependency? Does it have a transitive dependency? That is the normalization that you will have to do for each of your initial tables.
So,
Okay.
so Doctor, I want to ask, let's say after the first normalization, I found out that some of the table already don't have the what transition and partial dependency. So in the normalization, do I need to like redraw the dependency diagram for that entity? No need, right?
If there is no change, then you just say that all your tables are already in the third normal form. So no change from your ER diagram. Then you just note that. You just say that all the tables have been normalized. Are all not normalized. All the tables are already in the third normal form. And so you just continue with the original ER diagram.
Okay.
Unless you have one table which is in the second normal form, and then you have to normalize that to the third normal form, meaning that you have an additional entity, and so then you just redraw the new ER and say that after the normalization process, this particular table is has to be normalized. This particular table has to be transformed into a third normal form, which results in additional table, and so this is the new ER diagram, something like that.
Okay, thank you, Doctor.
Any questions?
Sorry, Doctor. So I have one more question, which is about the normalizations. So because you said that sometimes in certain situations that we might need to add, because just now we separate the assigned hours and the charge per hour, but after that you said that we may have to add back the charge per hour because we may have to do the calculations to work out the fees. So means that in our situations, in our assignment, we may have to use second normalized form, right?
Okay. In your assignments, I actually don't want you to do denormalization. Because I want you to join tables, because what you are doing right now designed for just for the sake of understanding different forms, and then understanding how to do queries by joining tables. So the more tables you join is okay. I want you to do that because we are not targeting performance for this particular assignment. Okay, so I don't want you to go back and join the tables. No. Okay.
Right. Yeah, understood. Thank you, Doctor.
All right.
Doctor.
Yeah.
I would like to ask if we are currently we are already using the top-down approach, right? When we identify all the relationship among entity, and then if there's many-to-many relationship, we already make a bridge entity. That means normalization process is just a process to check whether we have the redundant anomalous data or all the relationship between the attribute, right? Just the process to check again.
Yes, verification, yes.
So if a proper design entity relationship between each entity, the relationship are properly designed, that means normalizations normally is not that required, right?
No, it's not that it's not required. You still have to go through each and see whether do you have any transitive dependencies or not. You just double check.
Just double check lah. Okay, thank you, Doctor.
Right. Okay, any other questions? Everybody okay? So I will open the tutorial, then you can try, all right, and see whether you really understand what I was talking about. Okay, everybody happy? Let me close this.
Okay, class. Can I share one tips? Okay. Let's say you have a first normal form, and then when you want to transform to second normal form, Okay, so you just check if that relation consists more than one primary key. If there is more than one primary key, then there must be a possibility for partial dependencies.
The
Okay,
composite.
then you can check. Okay, if there is any possibility for partial dependencies, then there is a possibility to break the relation into few relations. Okay, and then for second to third normal form, if in each relation, if there is any more than one non-key attribute. Okay, let's say you have 3 attributes, so there is a transitive dependencies. But if that relation only consists of one non-key attribute, so there is no transitive dependencies.
Yeah, because there's only one attribute.
Yes, because there is so that's I always inform my student like that. So if for let's say from second to third, if there is only one non-key attribute, so there is of course there is no transitive dependency, so no need to check that relation.
Save time.
Okay.
All right. Any other
Thank you,
questions?
Fariza.
Yeah,
Doctor.
12 max for your entity, Nola. I think up to 15 is still okay. All right. Yeah. Questions again?
Hello, Doctor. I have a question. For the non-key attribute, do you mean it is the primary key and the foreign key?
No. Any key that is not the primary key. Sorry, any attribute that is not the key. That is not the primary key.
Okay, thank you, Doctor.
Key, that means they are dependent on some other attribute that is not the primary key. And that is a transitive dependency.
Okay, thank you, Doctor.
Any other question? All right. Okay. So everybody happy? All right. So please, I really strongly would like to remind everybody that please don't let just one person work on the database, because then you will be very rugi. The loss is yours. You may think, oh, okay, I don't have to do, let this person do everything, but you don't learn anything. And then remember, if you go for practical training, and then you will most of the time, unless you do strictly networking or something, but most of the time, even if you are in network, you still have to work with people, with systems, and then sometimes you have to take a look at, because you are interns, sometimes they will just ask you to do, look at this system, why it's not working, and then you have to troubleshoot, and sometimes you have to because the thing I'm saying is that, because I'm looking at some practical industrial training, and one of the lesson learned this person wrote was that like she just found out that every key must have every table must have a unique key. I'm like, is that what you just learned from the industrial training? I mean, you just found out that each table must have a primary key. I mean, this is something that we talked about in database class every time. Your table must have a unique primary key, and you don't want to do that kind of mistake when you go for industrial training. Malu lah kan. It's like macam what you UM student, you don't even know that a table must have a primary key. And then so you go out and tell, okay, we learned Oracle in our database class, but then when they ask you to do, you don't know. So don't let just one person do everything. Go, do it together, because you can share your screen, right? And then just, even if that person is doing it because he or she has that the thing on their punya computer, but you can still share the screen and together sit down and say, because when you key in, and you can say, you just key in wrongly, and then you can see the steps and so on. So I would really suggest, please do your project together. Okay? All right. Okay, class. Thank you. Kalau tak ada apa-apa lagi, so see you on Thursday. for
Okay,
the
thank you.
tutorial.
Thank you, Dr. Fariza.
Okay. All right. Okay. Thank you, Dr. Jan. Okay. Bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Okay. I'm gonna leave. Tak payah cakap thank you. I'm gonna leave. Bye.
Thank you, Doctor.